All right. Last unit before the AP test, so doesn't that feel kind of good? We only got one more unit before the AP test. Seniors, this is your last unit ever in this classroom. The black hole? All right. So we are going to start talking about trig, but before we do that, we need to learn how to read different graphs than we've ever read before a lot. We're looking at periodic phenomena. And what that means is, so far all our graphs have either went up or they went down or they've stopped. But sometimes graphs just repeat over and over again forever, right? Like think of your heart rate. If you look at that, it goes bleep, 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 bleep. Well, eventually, yeah, I guess. Father Time is undefeated. But can I represent that as a function? You can. When someone goes into AFib, that's actually a function that you can denote it. So we need to learn what kind of functions those are, how to manipulate them, what to do. They are periodic phenomena. Oh, yes. Trig is going to be the big one we do, but trig's not the only one. If you have different colored pens and stuff, it's really useful for this unit. I'm not going to lie. All right. So, a periodic function is any function that repeats itself over and over again. A cycle is one complete pattern of it. So what I mean by that is if I go from here to here, what happens after this? I'll repeat it and I'll do the same thing over again, right? So we call this from here to here, we're going to call that one cycle. Does that make sense? That's one cycle. How many cycles are on this? On this picture, yeah. But how many cycles will it do? Infinite. But yeah, could I have denoted this as one cycle? Could I have denoted this as one cycle? Yes, because I'm going to start over again, right? So where the cycle is does, as long as I get one full revolution of it. All right, so that's a cycle, a revelation. So then that is one cycle. The cycle is equal to the period. The period is the length of one cycle. So the period of a function is how often does it repeat. So one cycle is going to be one period. So this one, my period is 6, right? Because each cycle is 6, so it repeats every 6 units. So if I take this point and move it over 6, it will be at 0, right? If I move a point, it's actually a little bit more than 6. That's a big, but whatever. If I take this point and move it over 6, same point. Does that make sense? Cycle is my period. My period is my length of my cycle. Now my amplitude is the difference between my min and my max. Half of it. Think about it as the height of bump. So from here to here is my amplitude. From here to here is my amplitude. So where have I heard the term amplitude before? Sound, right? How does sound travel? In waves. So amplitude is just how big the wave is. The bigger the wave, the louder it is. Yes, you would have done this in physics. This actually, if you take physics, all this is the same. You will find the further you go in math, it just becomes a physics course. You know what I mean? Because why else are we doing the math but to explain natural phenomena, right? So why do we have this? To explain how sound and light and energy travels. This is why we do it. Or how weights or a wheel height, it's all physics. Everything we do this year is going to be physics, kind of. So if you like physics, hooray. If you hate physics, why are you here? All right. We good so far? Some of y'all, I'll be honest, some of you guys are going to love this whole unit, actually. If you like trig, some people, like, for me, I love trig stuff because it all goes together, all kind of clicks. Some of you guys are going to like this unit way more than the last unit. Some of y'all just, you'll be fine. It'll be fine. It always surprises me who ends up really loving this unit, though. All right. Let's find the cycle two different ways. This is almost straight from your homework. So if I start here, where do I repeat? Around 4, right? I know they don't match up on her. So identify one cycle two different ways. So I have a cycle from 0 to 4, right? Is there another way I could have marked it? Yeah, could I have done -4 to 0? Watch this. You guys want to do a wild one? Could I do 3 to 1? As long as I get one full cycle in it, right? So I have another one from, oops, I almost wrote 0. -3 to 1. Could I have done -1 to 3? -2 to 2? Could I pick any range of 4? Yeah, because the period's 4, right? Oh, yeah. So how big are both these cycles? So how long is one period? 4. Ooh, this isn't on here, but what would my amplitude be of this? 2. Huh?
It's always starts like
This is so the globiglugan. All right, let's look at this one. What's my cycle? I always like to do 0 to 3. Throw another one out of the hat. What? Nate? What? -4 to -1? Sorry. -4 to -1, does that work? Are there other ones? Yeah. How big are both my cycles? So what's my period? There you go. On this one, we're not going to, so do you see how these heights are different? No, what you do is, so it's -2 to 1, right? So it's 3 divided by 2 is 1.5. Because this one, my center's here. This one, my center would actually probably be here, right? Does that make sense? So you just divide it by 2. Add both heights up, divide by 2. Good question. That's a tricky one. All right. Ain't no mountain high, ain't no valley low. Ain't no river wide enough, babe. Ooh, look at this one. All right. Now we need, is this periodic, number A? Wait. You're telling me this one's not periodic? Well, what would a cycle be? From here to here, right? But Mr. Twilger told me that this value is going to have to be the same for my next cycle. Is it? That's not periodic. Because it doesn't repeat, right? Think about this. What's the range of a periodic function? It's limited, right?
Yeah.
Does that make sense? Like the range of this is only between -1 and 2. It'll never get above 2 and it'll never get below -1. What's the range of this one? -infinity to infinity. So it doesn't repeat. It just acts like it does. This is an oscillation around. Never mind. I don't even think we get into that. We're gonna take like classes. Take like fluids. Oh, that's no. Now on this one, so there's no period. It's just no. So for this one, does this one oscillate and stay within its realm? Yes. And what's my period on it? What's the distance from one peak to another peak? 4. You're going to find my method for period is I always look at the peaks. That's just how I do it. Could you compare the valleys? The reason I don't use zeros is how many, like, I have multiple zeros in a period that it doesn't work as well. Does that make sense? So what I do is I use my peaks or my valleys. Sound good? Do you think we're going to do it today? What? Oh my gosh. Put you on camera. I don't want to talk about it, TV. All right. Find the amplitude of each function. Now, these aren't as easy to see, but what I tell you for amplitude, what do we find? Find your total height, right? So what's my total height of this function from t to b, top to bottom? 3. But now I need to split that between my top and bottom. So it'd be 3 over 2. Am I doing this right? Find your total height. It's half the distance from your max to your min. So find your total height divided by 2. That part of our life is over. 1.5 is the same as 3/2. Max and the min. So what's my highest point? What's my lowest point? What's the height of that? What number is that? That'd have to be a -2. So how big is that from top to bottom, t to b? So I do 6 divided by 3. And again, think about like, that's my center of that. You know what I mean? Like, wherever half of that is going to be the center. That's going to come more into play when we have to graph these. We're going to have to make a fake axis to go up and down around. I do have good news when it comes to graphing these without calculator. There's actually like an algorithm, like a set way to do it every time. And we do it so much it gets pretty straightforward. Actually, if you can do this, the graphing of these is not bad. You just find the amplitude, the period, and you graph them. Are we good? Look at us flying. 3 examples in one day. All right. All right, let's sketch a graph. Speaking of sketching graphs, let's do it. All right, let's read some stuff. It has a period of 0.0004. Oh. That means how big is one cycle? That's one cycle, right? An amplitude of 2, which means I'm going to go up 2 and down 2, correct? All right, how do I graph it? Watch this, you guys want to see something wild? Oh, I'm sorry, let. Why can't I do that? We do it all the time. X is in thousands of dollars, right? So now I'm going to say X is in 10 thousandths. Does that make sense? So that means this makes this 0.001, 0.002. Now, if I denote this, do I have to actually write that on there? No, I don't. Because I know each one of these is a 10 thousandth. 10,000, right? Cool. Yep. You don't. It doesn't matter because it cycles. Where do you guys want to start it? We could start at the top. We could start at the bottom. Or we could start in the middle. We can do that because it doesn't tell us, right? So if we start at the top, we need to start at, why am I starting at 2? My amp is 2, right? Now, what's my period? 0.04. So for this graph, it'll be. So that means when I go to 4, what's that got to be? 2, right? Makes sense? Now, if I need to get back up there, I have to go down -2 as well, right? Where should I go down -2? Which one of these 3 points do you think? Why the 2? You gotta split in half, right? It needs to be equally spaced out if it's a sound wave. Which also means I'm probably gonna hit these zeros. Right? Do you want to do 2 waves of it? So then it'd be 4 and 8, right? It's going to repeat every 4. So my next one of these is 1, 2, 3, 4. Now, could I have graphed this a different way and it'd be 100% right? Don't draw this one. Could I have started at 0, 0? And I have to end at 0, 0? And I have to go to 0, 0? And I would go up to 2. It's really hard for me to graph these because once I put my hand up, it blocks my X and Y axis. Have you guys seen that? If I do this. Do you know what I'm saying? Like, it doesn't tell us where to start. So I could have started anywhere to sketch this representation. You know what I mean? I could have started at Valley. I could have started there. Now, when we get to actual graphs of functions, that's not true. You got to find your starting point. All right. Are we going to do it? Look at us go. Let's do more. As Queen once said, bicycle. You guys know where? Bicycle. Bicycle. I don't want to be monetized. All right. All right, let's graph this beast. So think about this. This is a really neat example. What are we measuring here? The height of the tire, right? So as a wheel turns, at time 0, what's my height of the tire? 0, right? And then here it's whatever this length is, right? And then here's this length. And then what happens here? They're the same again. And it goes back to 0. So height of a tire above the ground is a periodic function. Or height of a Ferris wheel, like how high you are off the ground. Periodic, right? Because you're going to reach the same number twice. Reach the amplitude once. You know what I mean? In one thing. It's almost like it's a circle. So they give us our graph right here. Oh, but Mr. Twilger, they left those blank. What's going to happen if it's periodic? 6, 9. It's a periodic function. It's going to go up and down, and then it's going to repeat the pattern forever. That's how I feel like my life is sometimes. All right. So what's my period of this? When do I do one full up and down? Wait, I guess I should ask this. Do you think it'd be easier to graph it first and then answer these questions? You guys want to do that? Let's graph the first 5 seconds. Now these I can just graph those points, right? 0, 18. 2 is 18. I'm going to cheat a little bit. 1 is 6. It's a sketch, so I'm going to do... That's pretty good. They have to be curved. They're going to be curved. Because if you do a straight line, down here that becomes a sharp point, and you can't have a sharp point on a graph because then it's not smooth. It's actually not, by definition, continuous at that point. They always are going to look like bells.
But I intended here.
That's fine. No one's going to bust your chops for it, for this one. Now what I'm going to do is I'm just going to repeat this they want 5 seconds, right? Wait, hold on. Just based on this, what was my period of this function? 2 what? Seconds. A lot of times period's going to be a time, right?
Yeah, you're right.
Now what's my amplitude of this? How big is this from 18 to 6? It's 12. what's 12 divided by 2? 6. There's an actual formula for it, but I don't like it's 1/2 max minus min absolute value of it. I know it's an absolute value. Like I don't like I say just use your graph. Always, because there's 2. Like it's your total height divided by the peak in the valley. So now they want 5 more seconds of this. But it's not that bad actually. Because what's my period? 2, right? So if I go over another 2 to 4, I know I'm going to have a big dot there, right? And then if I go over 2 to 3, I'm going to have another peak. Or a valley. Right? And then I can guess. Oh, well, yeah, because 2 more will get me to 5, right? See, trig's not as bad as what you guys said it was going to be. We're going to do it. We're going to do what I wanted. So I'm going to finish this one. The bell will probably get close to ring. Just try 1 through. You can. Tomorrow I'm going to give you the full day to work and watch a video, though, if you want. So, but let's do this. I got to make that video. Let's put it all together. This would be like what the question looks like on the test. All right. A periodic function goes through 5 cycles in 4 minutes. What's the period? It went through 5 cycles in 4 minutes. Period is like a rate, right? How many cycles per whatever. So they want it in seconds. So I have 5 cycles over 4 minutes, but wait a second. What's this want? So what's 4 minutes? 240 seconds. You see what I'm doing here? I'm finding out cycles per second. Because cycles per second will give me the period. Or as y'all would say in the physics world, the frequency. 240 seconds.
Yes.
What an idiot I am. I flipped it because I need to put on top my time. Because what's X in? Time. My bad. I apologize. I was doing frequency, not period. And I even said that. I'm sorry, internet. We'll learn about frequency later. Frequency is 1 over your period. So how many seconds does it take for 1 cycle? That's what we're trying to find out. 48 seconds. Yeah, we need time on top because my period's going to be in terms of time. Remember chemistry? 48 seconds per 1 cycle because period is how much X over time. Now, what if I have time? What if the period is 8 seconds? How many cycles will it go through in 30? It'd be 30 over 8, right? I have 30 seconds to do an 8-second cycle, right? Does that make sense? Because I have 30 seconds, and every 8 seconds it will repeat. 3.75 cycles. And lastly, the amplitude is 2.5, and its minimum is 0. Now, yeah, because if I graph it, that means what's my lowest value is 0, right? But now, to go up 2.5 only gets me halfway there, right? So I need to go up another 2.5. So what's the function's max value? 5. So again, the first questions were like straightforward. These are, do you comprehend? Obviously I didn't. Oh, what a day. What a day. Oodalolly, golly, what a day.